Okay, now, if you've not been following along the book, that's fine up to this point. But at this point, you really need to open up the book to page 154 and take a look at problem number 13. We're now going to get to areas where you're going to be required to remember a lot of stuff from the past to do this. I'm going to do 3 of these problems. We did 17, and I'm going to tell you that was an amazing problem to do, and I'm not going to ask you to do a problem that involves half angles, mainly because I know that half angles are something foreign to you guys, but it was a problem that took me quite a while to get done, and I was impressed with myself that I got it. We're not going to go that far. Now, when you go to college or university, there's a decent chance you're going to run into problems like number 17. But regardless, we're getting the basics down here. Number 13 says, find the rate of change of the distance between the origin and a moving point on the graph, y equals x squared plus 1. All right, so this is number 13. Y equals x squared plus 1. If dx dt is 2 centimeters per second. Now, I'm going to tell you that it's asking you to find the rate of change of the distance between the origin and a point on that graph. Now, if we were to go ahead and punch that into your calculator so you have an idea what that graph looks like, it should be a parabola. So go ahead and do that. And you should get something that looks like this, or this one right here. Now the question is, we're trying to find the change in distance. So we know that over a certain period of time, so let's say at point 0 over here, I'm not saying it is, but let's just take that. You find that distance right there, and then you find that distance right there, and you're looking at the change of distances between the two. Okay? So how do we find the distance from here? Now, this is really easy. This is 1, obviously. But this is actually the result of the distance formula, as is this right here. Now, what's the distance formula? Well, in this particular case, since we have x and y as our point, and that's 1 or 0 and 1 right there, but we're going to look at this. We were trying to find this distance right here. This is going to be the square root of x squared minus, or x squared minus y squared, or plus y squared. Okay? Now, that's the point of attack that we need to make here. And we want to get it so there's just one variable to make it easier to calculate. So what we're trying to find here is what is the rate of change of the distance. So we're actually looking at dD over dt. That's what we're trying to find. Now we got an x squared and a y squared. That's going to make life really difficult, but we can make life a lot simpler by taking this y here and plugging in the x squared plus 1 for that one right there. So I'm going to put that underneath the problem here. So d is equal to the square root of x squared plus, and then this becomes x squared plus 1 quantity squared, close parentheses. Now, I'm going to go ahead and multiply all that garbage out here. This is x squared plus 2x plus 1, and we resolve that. And then I'm going to combine these two together. So that means the distance is the square root of x squared plus x squared, which is 2x squared, plus 2x plus 1. Okay? Now, that's x squared. That's not right. Let me try that again. Okay, it's going to be x squared plus, and this is what is wrong right here. This is a square there, so that would be squared there. That should be 4th power right there. My bad. Now I'm going to combine those together, and I get x to the fourth plus 3x squared plus 1. Those exponents and signs will trick you up, and they do to me, that's for sure. So be careful with that. So when I find dd over dt, that is my change of rate of the distance. Then I can rewrite this as x to the fourth plus 3x squared plus 1 all to the 1/2 power. Okay? Now, using what we know from our calculus toolbox, this 1/2 is going to come down in front. This is going to change to a negative 1/2, so this becomes x to the fourth plus 3x squared plus 1 to the negative 1/2 power times the derivative of this. So that's going to be 4x cubed plus 6x. And of course the 1 drops out because the derivative of 1 is 0. And this will be dx dt. Okay, so when I rewrite this becomes numerator 4x cubed plus 6x. I got a negative denominator, so that's got to go to the bottom. The 2's in the bottom. So 2 times x to the fourth plus 3x squared plus 1 to the positive 1/2, since I've gone from numerator to denominator. So at this point then, there's not a whole lot more we can do because we're not given a specific x. So this is the formula that we're going to use to determine that. So they ever tell us what point specifically we're looking at in a moment in time, then we just plug in the x values that we don't really care about the y at all because they're going to be related. We can figure that out by plugging the x value into this if you know what the y is, but we just need the x values for this, which makes life a lot easier. Okay? All right. Number 15.